The second part of the EMI lesson is that the flux is directly proportional to the current. The flux induced is directly proportional to the current. That is, supposing the current is increasing 0 to 5 amps, that will cause a change in the d phi and induce an EMF. Similarly, if the current changes from 0 to 25 amps, a much more increased amps, that will cause greater d phi and a greater EMF to be induced. And so then this flux is always proportional to current, and flux is equal to L into I, where L is the proportionality constant, which is known as self-inductance. Self-inductance. Okay, so you know the flux, you know the current, you can calculate self-inductance. And let's apply this in Faraday's law. E is equal to minus d phi by dt. Instead of phi, you can write d by dt of Li, where minus L can be taken out and di by dt. Thus you get a new formula using current, rate of change of current. Can you see? And you get a new formula for EMF. You got a formula V is equal to minus N into d phi by dt, which is according to Faraday's law, and now you landed up getting E is equal to minus L into di by dt. Yeah. So now from this you know that the induced EMF and the current are opposing each other. The direction of the current opposes what's caused it, whatever. So then therefore L is equal to magnitude of L is equal to E by di by dt. Hence you can define the SI unit of this is 1 Henry. 1 Henry is the SI unit of self-inductance is 1 Henry. Okay. Is equal to 1 volt. 1 volt of EMF induced to 1 ampere per second of rate of change of current in itself, in the same coil, In fact, you know, when a coil is like this and it's connected to a source of DC and you have a key here, the moment you close the key, you know, there will be an induced current in itself. The current is flowing like this. It changes from 0 to say 5 amps, a finite amps, and a finite amps to 0 amps. In the exam, you don't say 5 amps, you say finite amps, and a finite amps to 0 amps. So during this change, by switching on and off, this change the current which produces an induced EMF. The induced EMF will oppose what has caused it. The change in the current, that's increasing current. In the case of switching on, in increasing current, the induced current flows in opposite direction. In the case of switching off, it will not permit the switching off. The induced current will be in this direction. So then it is inducing current in itself, or inducing EMF in itself. That is known as self-induction, the phenomenon. Self-induction is a phenomenon by which a varying current in a coil produces an induced EMF in itself. A varying current in a coil, okay, produces an induced EMF in itself. That's known as self-induction. It's a phenomenon, okay. Whereas self-inductance is the ratio of EMF induced to the rate of change of current in itself, in the same coil. In the EMF induced in the coil to the rate of change of current that's occurring in the coil. Rate of change of current in the coil. The ratio of this one. That's how 1 Henry is 1 volt of EMF induced to 1 ampere per second of rate of change of current in the coil. The same coil. There's no self-induction. Okay, this is about self-induction. If it's mutual induction, it will be a little different, where you have a current and a key here, a battery, and suppose it's switched on and switched off. There will be an induced current in the adjacent coil. There will be an induced current, galvanometer. This induced current is adjacent coil. That phenomenon is known as mutual induction. Mutual induction, okay, and self-inductance is referred by L. A mutual inductance is referred by M. That's all. That is also E by di by dt, no change. E is equal to minus M into di by dt. It's the same thing. Instead of L, the self-inductance, it becomes a mutual inductance. That's the only difference. So during the switching on and off, there's an induced current in the adjacent coil. This phenomenon of mutual induction is very important because you must have seen transformers where, you know, there is a primary coil with lot number of turns, a larger number of turns, and a secondary coil with a small number of turns. You'll have two coils here facing each other. In the case of a transformer, this is a primary coil and this is a secondary coil. You know that for long distance transmission they use really high voltage. Very important. They'll transmit, say from a hydel power plant, if it's coming to different various states and cities, it has to be transmitted with a very high voltage in order to conserve power. Otherwise there will be a lot of wastages of current, wastages of voltage, and so therefore in order to conserve power, they will transmit at a very high voltage. So if you stamp on those wires, you will just get electrocuted directly, no shocks, just electrocuted at such high voltage. And this is step down to a low voltage. Say if supposing you need only 400 volts or 420 volts. Okay, and near your house you must have transient transformer that comes from the EB office. So probably the EB office is transmitting to you at 420 volts, which gets stepped down to 220 volts, which is your basic needs. You've seen transformers, so then there's something called a step down transformer, and the current comes to your house, and and the current goes back to the EB office. There's a live wire and neutral wire where the current comes in like this and then goes back, and the process of which you consume, and you have a meter, the consumption is recorded in the meter. So the current continuously flows. So then you need, just like you need a step down transformer, when it flows back you need a step up transformer, where the number of turns in this is less and this will be more, the voltage will get stepped up. Okay, so then I hope you understood that point. So then when you see that the current is coming from a hydel power plant to a village, step down by 6000 voltage to 420 volts, you see that the number of turns is more here. And EMF is equal to minus N into d phi by dt according to Faraday. As N is more, E is more. So then the 6000 volt is nothing but the EMF is more, because the number of turns is more. But I would say the current is less. The EMF is more, number of turns is more, but the current is less. And whereas here, if you see the number of turns is less, the EMF is less, but the current will be more. And how is that? How does it work? You know that in a single wire, V is proportional to I, so you must think you must be thinking of and V and I being directly proportional. But this is a different concept where the power input is equal to power output. The power input will be the voltage of this. Supposing the voltage is V1 or an E1 or whatever, V1 I1. The power is Vi, so V1 I1 is equal to V2 I2, which is for power here, for output. V1 by V2 is equal to I2 by I1, and therefore you understand that they are inversely proportional. So then therefore in this case the EMF is more, the current is less, and when it steps down by the transformer, from primary to secondary, when it steps down, the number of turns is less, the EMF is less, the current is more. So this is how, so you understand that a long distance transmission, they use very high voltage transmission, and there is a necessity for a step up and a step down transformer. So it's not necessary that the number of turns is always the same. It can be two different number of turns, where it's depending on the step down or step up. We'll come across transformer in the next chapter, but having said that, I made you understand this phenomenon is based on mutual induction. This phenomenon here is based on mutual induction. The varying flux with one coil produces an induced EMF in the other coil. That's the same phenomenon. So then that's about it. That phenomenon of mutual induction is over. So now coming back to self-induction, the phenomenon of inducing an EMF itself is known as self-induction. And therefore you come across a word called inductor. What is an inductor? You must have seen that the olden days tube lights will have a choke. A choke is like a cylinder in which a copper coil will be closely wound around. You can surf the net for an inductor. This inductor is similar to that. Okay, so what is the purpose of an inductor? It stores energy. It stores energy in the form of magnetic field. Magnetic field. The difference between a capacitor is capacitor stores energy in the form of electric field. if you will get, it's half into epsilon naught into capital E square will be the energy of CV square, after which you substitute C as epsilon naught into A by D and V as E into D, E square. So energy density of a capacitor, which is U by V of a capacitor, is half epsilon naught E square, which shows that the electric field, the energy stored in the form of electric field, whereas in the inductor, energy is stored in the form of magnetic field. So then when you are switching on and off the switch, the current decreases to 5 amps to 0 amps, 0 to 5 amps. At that time, the tube light needs a steady current, and the tube light itself needs a steady current. Say for example, the light needs a steady current. It will not accept this increase and decrease of current. So what happens is, at that time the inductor supplies the energy. That's the purpose of the inductor. So then let's talk about energy stored in an inductor. Very, very important. Energy stored in an inductor. You know how to find energy. V is equal to W by Q. So W is equal to V into Q. Yeah, so this here dW becomes V into dQ. In the whole lesson, V is not V, V becomes small e, which is the EMF. And you know that it's minus L into di by dt, okay, into dQ. And dQ by dt itself is I. So dW is minus L into I into di. So I can integrate both sides. So minus L constant, I di is I square by 2. And this is work done, or energy itself is half Li square, just the magnitude. So half Li square. Just like in a capacitor, it's half CV square. Here it is half Li square. That's about energy of an inductor, half Li square. Okay. Okay. Now let's talk about the solenoid. Self-inductance of a solenoid. Self-inductance of a solenoid. Okay. Suppose you have a solenoid with many number of turns, more number of turns than an inductor. So let capital N be the number of turns, and E is equal to minus this capital N into d phi by dt is the EMF induced. Yeah, and you know that E is equal to minus N into d by dt of inductance. Flux is nothing but V dot ds, which is V into A. Area of cross section is a constant. So therefore you get minus N into A constant dV by dt. And what is B of a solenoid? You all know it's mu naught into small n into I. And you can substitute small n as capital N by L into I, because there's a capital N again. So it will be helpful. So d by dt of mu naught into capital N by L into I. So capital N square minus N square A mu naught by L into di by dt is what is E, and thus it gets to the form minus L into di by dt. Therefore, self-inductance itself, L is equal to N mu naught N square A by L. It's easy to remember like that. So self-inductance for solenoid is mu naught N square A by L. You understand? You started with Faraday's law. You ended up associating with the minus L into di by dt from minus N into d phi by dt. And therefore, you found what is self-inductance. So now energy of a solenoid, energy stored in a solenoid. In other words, for an inductor it's half Li square, and all that's going to change for the energy of a solenoid is L self-inductance, which is here. So substituting that is mu naught N square A by L into I square is what is energy stored in the solenoid. And you do not want this I, you want to write it as B is equal to mu naught into small n into I, because you need the magnetic field. Yeah, the energy stored in the solenoid is in form of magnetic field. So I is equal to B by mu naught into small n. On substituting here, mu naught into capital N square A by L into I square is B square by mu naught square into small n square. And small n square can be written as capital N by L. Correct? So then half into mu naught into capital N square by A by L into B square by mu naught square into capital N square and L square. So with this L and L get cancelled, the mu naught and the one of the mu naught get cancelled, N square get cancelled. Can you see? Can I circle the area? Can I circle the area into length, which is the volume? And so then energy per unit volume, U by V, which is A into L, will be half into B square by mu naught. So thus you get the energy density. This is the energy density of a solenoid. of a solenoid. And can you see energy density of a solenoid is half V square by mu naught, whereas energy density of a capacitor is half epsilon naught into capital E square. So this is just for you to recall. So this is electric field, magnetic field, and this is the energy density of a solenoid. Okay, so that completes this. Okay, very important energy density of a solenoid. Next is about mutual induction. Yeah, I think it's mutual induction. And you know what is mutual induction? E is equal to minus M into di by dt, where this M is mutual inductance, and this phenomenon of induced EMF due to varying current is known as mutual induction. So let's consider two different solenoids. Okay, with the same number of turns or whatever. Okay, it doesn't have to be, but let's assume it has the same number of turns. And let there be a current I1, or for now let's consider this has got N1 turns, a current is I1, and the area of cross section is A1, and the magnetic field that is produced because of this current carrying solenoid is V1, which is going to induce an EMF in this coil, which is the second coil. So induced EMF in the second coil due to the first coil is E21. So let us write what is E21. What is E21? You know the number of turns in this is N2, and the area of cross section is A2, and the current that's flowing here is I2, and the magnetic field produced by this is V2. But we are going to talk about E21, which is the induced EMF in the second coil due to the first coil's magnetic field, which is minus N2 into d phi by dt, where phi can be written as, replaced as B dot ds, which is B1 into A2. Only the magnetic field due to 1 is responsible for this change, correct? Induced EMF in second. So you know that it's minus N2 into A2 is a constant, d by dt of what is, since B1 itself is mu naught into small n1 into mu naught I1, and you can write small n1 as capital N1 by L1 into I1. So you can replace here B as mu naught into capital N1 by L1 into I1. So grouping all the constants out, you get mu naught into N1 N2 A by L1 di1 by dt will be the EMF induced in the second coil due to the first coil. See, similarly, the EMF induced in the first coil due to the second coil will be just the opposite of this, correct? Magnetic field will be because of B2 minus N1 d by dt of B2 into A1. The magnetic field B2 itself is mu naught into N2 into I2, which is mu naught into capital N2 by L1 L2 into I2. Substituting that here, you will finally get this formula similar to this, which is minus mu naught N1 N2 A by L2 di2 by dt. di2 by dt. If I1 is equal to I2, and if I1 is equal to I2, and N1 is equal to N2, L1 is equal to L2 is all equal to I and N and L, the whole formula can replace, and this is the mutual inductance, can you see? And this is the mutual inductance, because it comes as E21 is equal to minus M21 into di by dt, and this is like E12 is equal to minus M12 into di2 by dt or whatever. So then this is mutual inductance, and this is the mutual inductance, and a general formula for mutual inductance therefore is, if it's the same number of turns, it's N square A by L into di by dt, the current is same. So then if you see that this is similar to the self-inductance, but this will never be the case, because the number of turns is not going to be the same as you saw in the transformer. But this is, however, you can write it as a general format considering this. And you should know that the relationship between self-inductance and mutual inductance. In mutual inductance, the flux, some amount of flux can get leaked into the outer atmosphere. Flux. All the flux change is not going to produce an EMF in the other coil. Some amount of flux will get leaked. There will be flux loss. Yeah, so then supposing you take the self-inductance of this, which is L1, self-inductance of this, which is L2. Individually L1 and L2 are the self-inductance. Okay, so you multiply the mutual inductance of one produced by the other. Say it is m square, considering one is m, another is m square. It will not be equal to L1 into L2. It will not be. The self-inductance will be more because there is no flux loss in self-inductance. So there will be k times, it is actually m is equal to k times root of L1, L2. Because some amount of flux, this is a factor due to which some leakage has occurred. Leakage of flux has occurred. So then the product will not sum up to mutual inductance products. Okay, so that's about it. And I did some numericals. Let's redo this numericals. We'll take that page once again. Well, let me run through the numericals from the PDF. That's easy. Okay, so then let me run through the numericals from the PDF. This card, I don't need it. I have a separate file where I've stored EMI. Yeah, here. So this is the first part of the video that I've uploaded. All this is there in the first part of the video. And pan omega, sin omega t. Okay, this is the second part. The PDF has the second part which I've explained there. Okay, and energy of an inductor, then inductance of a solenoid, energy of a solenoid, what is mutual induction, what is the, okay, this is just repetition, what is energy density of a solenoid, then what is mutual induction, inductance, and how do you calculate the mutual inductance of a solenoid. So it's all done. Okay, then the first sum, a long solenoid with 15 turns. Can you see this roll? I'm just going to run through. Can you see a big solenoid? Below, I've drawn a big solenoid, 15 turns per centimeter. So 15 turns per centimeter. On the right side, can you see the 15 turns is for 1 centimeter for 1 meter, because I want small n, which is the number of turns per unit length. Number of turns per unit length. For me, length is 1 meter. So for 100 centimeter, how many turns are there? First write that, 1500 turns. Okay, now has a small loop of area 2 centimeter square placed inside normal to its axis. Can you see the purple color loop? If the current carried by the solenoid changes steadily, so the bigger solenoid, the current is changing steadily from 2 amps to 4 amps. Okay, in 0.1 second. So the current is varying from 2 to 4 amps. What is the induced voltage or induced EMF in the inside loop is mutual inductance phenomenon. So then E is equal to the minus N, which is number of turns of the purple loop, which is 1 turn only. That's because it's got only one single coil, into d phi by dt. You can write it as 1, and d phi by dt is nothing but a B dot ds or B dot area is constant, and area is of the purple color loop. Yeah. So only the magnetic field B is due to the black color big coil. So then A is area of the loop, which is given in the question itself. It's 2 centimeter square, so 2 into 10 to the power minus 2 the whole square. 2 into 10 to the power minus 4, that's all. Area itself is 2 into 10 to the power minus 4. And you get mu naught into small n into I as B, which is all because of the black color solenoid. And mu naught's value is 4 pi into 10 to the power minus 7. Small n is the number of turns of the black color coil, which is 1500 turns. We have found that. And I, okay, when you substitute, the di by dt can be grouped because di is 4 minus 2 amps and a time taken is 0.1. Directly substituting will get the answer. So let's go to the next sum. A rectangular loop of side 8 centimeter and 2 centimeter. Can you see the length and breadth? Always, which is not changing should be considered as L. Which is changing should be considered as X. What is changing in this? When you're moving it in this direction, the magnetic field is inward, I'm moving it in this direction. The variable will be X here. This will be the variable. The 8 centimeter will remain a constant, so I can call 8 centimeter as L. Because I'm directly going to put a formula will be. These are book back questions only. The magnetic field has been given. The rectangular coil's length and breadth has been given. Here length will remain constant when I'm moving it upwards. When I'm moving it sidewards, which is a constant, that I'm calling it as L, and which is a variable, the x will vary as I move to the right, and so that L and x get interchanged. I am going to apply BLV. B, you know, L is the unchanged length, which is 8 centimeter for the left side, and unchanged length here will be 2 centimeter. And to velocity, the velocity with which it's getting pulled is 10 to the power minus 2, 1 centimeter per second is 10 to the power minus 2 meter per second. So you substitute those respective values, you get the EMF. The second part of the question is how long does it take for the voltage to last? The EMF will be induced as long as there is a varying flux. How long will the flux will vary? Until this x completes, this x length completes the whole length and comes out of the magnetic field, which is the 2 centimeter, until the x completes the 2 centimeter. So then the distance by velocity is time, so 2 by the velocity, and here until the 8 centimeter, complete 8 centimeter crosses the magnetic field. So then it's distance by time, it's 8 by time is distance by velocity. So there you get that. Okay, so then let's go to the next question. A 1 meter long conducting rod rotates. Okay, angular velocity has been given. We decided it's going to be half will be, right? But linear velocity is r times angular velocity, in that case L, not r, because the rod's length is L. Substitute, you get half b L square omega. L length of the rod has been given as 1 meter. Omega is 400 radians per second. The magnetic field has been given as 0.5 to expand the question. Just a matter of substituting. So, a circular coil of a radius 8 centimeter. So, we learnt about a rectangular coil rotating in a magnetic field, yes, between north and south. It is a circular coil, but still going to rotate. So, in this case, the length was L into B. We took it as A. In ban omega sin omega t, we took it as A. Doesn't matter, area is pi r square. We are going to still consider it as A. Doesn't matter. So then, whether it's rectangular coil or circular coil, rotating about its diameter in a magnetic field means you can only relate it to this. 50 radians per second. So the angular velocity has been given. Omega has been given. In a uniform magnetic field is given. Average, obtain the maximum EMF. I told you, ban omega, so E is equal to ban omega sin omega t. That will be the answer. And you know that this is similar to E is equal to E naught sin omega t. Therefore, E naught will be your maximum EMF. They will give you a resistance obviously in the sum, 10. So you can find I naught is equal to E naught by R, which itself is ban omega by R. Okay, once you know I naught and E naught, they will ask you power. Power is VI, which is EI. But you got only E naught. And the relationship between E and E naught is E is equal to E naught by root 2 and I is equal to I naught by root 2. Why is it? I have told you, explained in the graph. The graph goes like this. This is maximum E naught and E will be somewhere below. And it will be lesser than E naught by, E is equal to E naught by root 2 and I is equal to I naught by root 2. Therefore, E naught into I naught. E naught into I naught by 2. So just find E naught, find I naught, multiply them divided by 2, you get the power. So let's go to the next question. A horizontal straight wire, 10 meter. Can you see a straight wire, okay, purple color wire extending 10 meter from east to west. So from east to west is falling at the speed of 5 meter per second at right angle to the magnetic field. So I mark the right angle inward so that it's coming at right angle to the magnetic field. And in the question it says BH, the horizontal component of the magnetic field itself is given, the horizontal component of the magnetic field. So imagine this is earth and the horizontal component will always be on the surface of the earth. Okay, and the space above the earth, this is falling down, the rod is falling down. The component which is perpendicular to the velocity is BH component. So when you put BLV, we have to put BHLV and we can substitute BH value directly. That will give you the EMF induced, and you can use the, this is about induced EMF, you can use the right hand rule to point which direction is your induced current. The induced EMF will be from west to east. Just make sure you point your middle finger from, let's right hand rule. You know that the velocity's direction thumb has to be pointing to the direction of velocity. And the index finger should point to the direction of the magnetic field, which is inward. And when you keep it like that, obviously your middle finger will be here pointing to the direction of the EMF induced, which shows it's going to be from west to east. So therefore, you know the west end is at a higher potential. Next question is Please read the question from the textbook and then look at the answers here. The current is reduced from 5 amps to 0 amps in a time of di by dt, in a time of 0.1 second, di by dt is known. And EMF is given, you know, direct formula E is equal to minus L into di by dt, thus you can find self-inductance, it's E by di by dt, you get 4 Henry. Then mutual inductance of 1.5 Henry is given, then E is equal to minus M into di by dt. The current increases from 0 to 20 amps at a time of, okay, di by dt is known, you can find it. Okay, what is the question all about? Ninth question in the textbook. But they'll ask you, not for the EMF induced, they'll ask you for change in the flux d phi. You have to equate the Faraday's law's formula and the final formula with mutual inductance. Equate them both. dt will get cancelled because time will not be given in this question. I don't think the time is given. I don't think the sum had they had di, but it didn't have dt. Okay, I'm not sure where the sum is, so I have to search for the sum now. Okay, but I'm sure you can read the sum from the textbook. So equating di by dt is equal to minus m into di by dt. dt gets cancelled. d phi itself is m into di. Okay, you don't need the time. You don't need the time here because you're equating these two, so you get a formula. Or you can even say flux is proportional to I. Flux is equal to m into I, so d phi is equal to m into di. You can even say like this. And so then, you know, m and di, that is enough to find the changes of flux. That's that much Weber. Okay, so let's go to next. Okay, the next sum is about a jet plane. Its wings, jet plane is going from east to west, and its wings, I've drawn the wings as 25-meter long, and I'm just comparing it to the Earth's surface. The horizontal component BH is along the surface and B vertical is perpendicular, and the way the velocity is going is perpendicular to only the vertical component. So when I do BLV, I have to do BVLV. So I have to find the vertical component because they have given delta. I can do B sin delta as BV and then substitute that. Horizontal component is of no use because here the horizontal component is parallel to the velocity. I need a component of magnetic field which is perpendicular. Yeah, so then BVLV. Okay, so then you get the EMF induced. So let's go to the next question. The questions are not here, but the answers are here. I'm sure you can look at the question from a textbook. It would have been given that the magnetic field is along the magnetic field. Yeah, I'm just trying to figure out rate of change of magnetic field is given. The initial magnetic field was 0.3 Tesla, dB by dt has been given. Okay, and a resistance is given. Obviously, they're going to talk about current or power to find, because when I have resistance, I know it's obviously EMF by R will give me current, and the power is VI. Okay, so let me see. E is equal to d phi by dt, Faraday's law. You can forget about N because there's no number of turns here, and flux is B dot A. Yeah, and A is a constant, so you get dB by dt, which itself can be substituted. dB by dt itself is 0.02 and area itself is known. You can find the EMF induced. Once you know the EMF, you know the resistance, you can divide EMF and resistance to get the value of current. And once you know the current, you can find the power which is using VI. Directly you know V and I. Unlike the previous one where you know E0 and I0, so you have to do E0, I is equal to VI, which is E0 into I0 by 2. There is E0 by root 2 into I0 by root 2. Okay, unlike that sum, this is directly current and EMF. Okay, so let's go to next question. It's the 12th question, where the magnetic field is changing with respect to X. Okay, you see the magnetic field is along the Z-axis, and every point along the Z-axis magnetic field keeps changing, and I'm moving a square coil in XY plane along the right direction, along the positive X direction. As I move, the magnetic field at every point is going to change depending on the position 2, which is dB by dx, depending on the time 2, which is dV by dt, because it's been given in the question that the magnetic field changes with the position as well as time, in space and time, if you read the question. So dV by dx and dV by dt, both of whose values are given to be the same, but this Tesla per centimeter, this Tesla per second. That's all. That's only variation. Resistance has been given, so I know that I'm going to somewhere find the current or power. Let's see. Now let's say E is equal to minus d phi by dt, d by dt of B dot A, where A is a constant, you get dB by dt. You know what is dB by dt directly here. Yeah, you can substitute that value. Yeah, that's what I've done here. Okay, that's what I've done here. dB by dt I've directly substituted. But there will be a negative sign here, but since dB by dt itself is decreasing, and the question will say that the magnetic field is decreasing along z axis. So negative and negative dB by dt will get cancelled, so answer will become positive here. In this case, you can directly substitute dB by dt, that's what I have done, and the area of the loop is 12 centimeter, 12 into 10 to the power minus 2, the whole square. And what have I done here? I wrote dB by dt. I have dB by dx, and now to substitute that I am multiplying and dividing by dx. So that the dx by dt will become velocity. Can you see? I've clubbed it like this. This is velocity. And a dB by dx can be directly substituted. The velocity is given as h into 10 to the power minus 2 meters per second. So substitute that, and this is a different sum. You get an EMF due to the position, and you get an EMF due to the time, and you have to add both the EMF so that you get the resultant EMF induced. And to find a current, E by R resistance is given, you can find a current in the circuit. So let's go to next question. Okay, this is about the loudspeaker sum. I vaguely remember, I don't have the questions with me. Between the two loudspeakers, we can consider it as north and south pole. Between them you are positioning a coil, can you see, with many number of turns, yeah. So E is equal to minus n into d phi by dt, because there will be a magnetic field between the north and the south pole of the magnet. And here they have given, the question has got number of turns to be 25, area of cross section to be given, a charge is given, a resistance is given. So okay, I don't have a current but I have a charge, okay, fine. I know that when okay, yeah, d phi by dt can also be written as phi 2 minus phi 1 by t, change in the flux by t. And as you know, the change initially, actually you are bringing in this loop here in this plane, and suddenly you will rotate it by 90 degree. So when you rotate it by 90 degree, no magnetic field pass through. So initially there is a magnetic field passing through, then there is no magnetic field pass through, and this is going to cause a change in the flux. So then what is the change in the flux? Phi 2 minus phi 1, and when it's 90 degree there is no flux. The final position, when the coil will be like this, can you imagine one behind the other, you know, like that, going like that three-dimensionally. You see that the flux lines will be on the same plane as the coil, so no flux will pass through at all. So the flux can be taken as 0 in that case. The flux in the initial position, which is the kept position here, where maximum flux will pass through, so B dot ds or B dot A. So this minus n and this minus will become plus n in dA by t, and so you get this formula. You get this, and you do not know what is t. T has not been given in this question, but charge has been given. And you know, EMF is also voltage, which is IR, and I can be written as Q by T, and you are substituting this Q, and you can equate this EMF with this EMF so that the T and T get cancelled. You get a new formula, NBA is equal to QR. Beautiful sum where you can equate both and find the value of magnetic field directly, even though the time is not given in the question. So next is this 14th question, which I have to continue from tomorrow's class. Yeah, so then we'll do it tomorrow and we'll finish off from here, okay? So until here I've uploaded in the YouTube.